These are the 7.6 notes for trig. We're going to talk today about double angle identities. So if you could, make sure you have your unit circle. We're going to look at the back side of our unit circle. On the back side, we have several formulas, and we're going to go all the way down towards the bottom here, where we see this double angle identities. And these are the ones that we're going to be focusing on today. Notice there is one that is a sine, and then notice that there are three that are cosine. And then lastly, you have one that is tangent. We're not going to focus on our tangent during this lesson. In fact, we're not going to focus on it at all. We're just going to focus on the sine and cosine. All right, so I'll keep that here so we can flip back to it. Let's look at our first problem. For all problems, assume that theta is a positive acute angle. That just means that we're not going to be having to deal with any negatives as far as the sides go. So given cosine of theta equals 8 over 21, they want us to find cosine of 2 theta. So cosine 2 theta is the formula that we want to get from the back. Now remember that there are three of them, and we want to do that based on which piece of information we're given. So we're given cosine. So as we look at the back side here, I've got this first equation, which has a cosine squared and a sine squared, but I don't know sine squared. They did not give me that. So I don't really want to use that one for this. The next one, again, is 1 minus sine squared, but I was not given sine. This last one here is 2 cosine squared minus 1. That's the one I want to use because I already have cosine. So we'll use that third one for this problem. I'll copy down everything I see after the equal sign. We'll write that as 2 cosine squared theta minus 1. We know cosine, so I'll write this as cosine is 8 over 21. And we'll just make sure we square both of them to get that cosine squared. We'll bring this down as 2 over 1. Then I'll just leave that minus 1 over 1 there. All of this part is going to be multiplied together. So 2 times 1, 8 squared is 64. 21 squared, type into my calculator. It's 441. Still need to multiply those two together, and feel free to do this in a shorter amount of steps if you want. 2 times 64, 128. 1 times 441, 441. And now this 1 over 1 right here, remember I can make that into anything that I want to get a common denominator. So if my denominator is 441, I'm going to make that into 441 over 441. That's the nice thing about that being a 1 right there. It's pretty easy to get common denominators. Then we'll subtract. 128 minus 441 gets me negative 313, and I keep that common denominator. And there's my answer. All right, let's try the second problem. Sine of theta equals 2/7. I want to find cosine of 2 theta. So I'm going to look to the back of my unit circle, erase some of this stuff that we've done here. And remember, we have 3 cosine formulas that we can use. 1, 2, or 3. They give us sine, but they don't give us cosine. So if we were going to choose one, you want to choose the one that has the sine in it and doesn't have a cosine, because we don't know cosine. So it's going to be this one for this problem. That'll be the easiest one for us to find the answer to. So again, because you're given sine, you want to choose the equation that just has a sine. This one has a cosine. We don't know cosine. Cosine, we don't know cosine. They didn't give us that information. So 1 minus 2 sine squared theta. And this problem is going to work just like the last one did as far as squaring things. I'll put 1 over 1. I'll deal with that at the end. Again, you're going to focus on your multiplication first. 4/49. I'll multiply those together, just bringing over the 1/1. 2 times 4 to get 8. 1 times 49 to get 49. Then I'll have to make common denominators. So 1/1 can turn to 49/49. That way I have a common denominator with that 8/49. Once I subtract those, I get 41/49. All right, example number 3. We are given cosine of theta equals 3/5, and we need to try to find sine of 2 theta. So let's look on the back side of our unit circle for sine of 2 theta. All right, so the thing about sine of 2 theta is there is only one formula, which means we are forced to use that formula even if we don't have all the information we need yet. So we're going to choose the only formula available, choose sine theta, cosine theta. And this is all just one big multiplication problem. So I know 2. I'll put 2/1. I don't know sine, but I do know cosine. So cosine is going to be 3/5. So off to the side here, we're going to have to find sine of theta. So here's how we're going to do that. We're going to draw a triangle. Label the sides. Go back to the problem. Cosine is 3/5, which means cosine is A/H. A is 3. Put that on the A side. H is 5. Put that on the H side. And then to find the missing side, you want to check first under your Pythagorean identities on the front of your unit circle. Sorry, your Pythagorean triples right here. So notice one of my sides I have is 3. The hypotenuse is 5, which means the missing side must be 4. If you forgot about that little set of numbers, you can always just do Pythagorean theorem. It's going to get us a side of 4, which means sine is 4/5. So I'll just put 4/5 right there in the sine spot. And then all this is one big multiplication problem, so I can multiply all the way across the top. 2 times 4 times 3, 24. 1 times 5 times 5, 25. There we go. All right. The backside is just more of the same problem, so if you feel confident and want to stop the video, that's fine. I'll run through the rest of these just to make sure. You might also want to pause the video, try each of these problems, and then play it back to see if you got it. Example 4, sine of theta equals 15/16. We want to find sine 2 theta. Again, on our unit circle, there is only one equation for sine 2 theta. Let's jot that down. This time they give us sine. I'll put sine right where that goes. And now I need to find cosine. We draw the triangle. Label the sides. And then come over here to the problem. We know sine is O/H, so then I can put the 15 on the opposite side and the 17 on the hypotenuse side. I'll check my Pythagorean triples on the front of the circle. I'm looking for a 15 and a 17. You see that right here. 17 is the hypotenuse, so I'm good, which means my missing side is 8. I'll put my 8 right there on the adjacent. So then cosine is A, 8 over H, 17. And we can put that into our multiplication problem. Multiply all the way across the top, 2 times 15 times 8, 240. 1 times 17 times 17, 289. All right, example 5, sine of theta equals 60 over 61. They want us to find cosine of 2 theta. Now remember, cosine 2 theta is the one that has 3 formulas. So as we look to the back here, I've got 3 formulas to choose from. 1, 2, or 3. Remember, we need to think about the information that they give us. You could use any of those 3, but you would have to make a triangle like we did on the last couple problems. But if you choose the correct one, you don't have to do that step. So they gave us sine, so we want to choose the one that just has the sine in it. This one. 1 minus 2 sine squared theta. And that way we don't have to make a triangle. All right, I'll put 1 as 1 over 1, 2 over 1, and 60 squared over 61 squared. Remember, you're going to deal with all the multiplication first. Sixty times 60, 3,600. 61 times 61, 3,721. Multiply one more step here. You are starting to get pretty large numbers. That's okay. It happens sometimes depending on how large your sides are. So we started off with numbers like 60 and 61, so the numbers are going to get pretty big once we square them. All right, now it's time to subtract. So let's get our common denominator there. So I need a denominator of 3721, so I'll turn these both into 3721. And then I can bring over my 7,200. So once I get those common denominators, I've turned 1 into 3721 over 3721. We can subtract. We get negative 3479 over 3721. All right, last one. Example number 6. Find sine of 2 theta. Sine of 2 theta, notice again, only has one option. So we must use that equation. We'll write down what's after the equal sign. 2 sine theta, cosine theta. All right, so 2 over 1 times, and remember they didn't give us sine, so that's what we have to find over here. Just kind of leave it as a blank spot right now, and I'll fill in my 48 over 73 for my cosine. Create a triangle. Label the sides. Come back to the problem. Cosine is 48 over 73. That's A over H. Then I could put the 48 on the adjacent side and the 73 on the hypotenuse side. All right, let's double check our Pythagorean triples on the front of our unit circle and see if we have anything that large on there. I don't see any numbers that are as large as 73 or 48. So we'll have to do the Pythagorean theorem in order to figure out this missing side. All right, so a squared plus 48 squared equals 73 squared. I'll grab my calculator, 48 times 48, 2,304. 73 times 73, 5,329. Subtract 2,304 from both sides to get 3,025 and square root that, which gives me 55. So thankfully that's still a perfect square. We'll put that 55 right there. So 55 sine is going to be O, so 55 over H, 73. All the numbers that we're dealing with in these problems should turn out to be perfect squares, so you shouldn't have to deal with any square roots. Then we multiply all the way across. 2 times 55 times 48 gets me 5,280. And 1 times 73 times 73 gets 5,329. There's your final answer.